Hello, my dear students. Welcome back. I know. Exams are just around the corner, and the pressure is building up, but please don't you worry. Today, we're going to tackle a chapter that's not just easy, but it's actually super interesting. We are going to make symmetry so simple and fun, it'll become your secret superpower in the exam hall. Okay, let's dive right in. Just take a look at these two pictures. On one side, we have the magnificent Taj Mahal, and on the other, this beautiful, beautiful flower. What do you think is the one thing that makes them so pleasing to our eyes? There's this kind of hidden pattern, a special kind of balance, right? Well, that special balance has a name. It's called symmetry. And what's really amazing is that it's not just in big monuments or pretty flowers. If you start looking closely, you'll see this pattern of repeated parts all around you, from a butterfly in your garden to the beautiful Rangoli designs your mom makes. It's everywhere. So what exactly is symmetry? Let's keep it very, very simple. A no-tension definition. Imagine you're looking into a mirror. What you see is your reflection, right? A perfect copy. Symmetry is just like that. It's when one half of any shape is the perfect mirror image of the other half. See? Simple. All right, let's move on to our first stop and see how this whole mirror idea really works. The first and simplest type of symmetry is all about one perfect fold. We call this line symmetry. So what is a line of symmetry? Don't get scared by the name. It's just a fancy term for that magic folding line. It's the line that divides a figure into two perfect mirror halves, two parts that will sit exactly on top of each other if you fold them. And this slide shows it perfectly. Just take a simple piece of paper. If you fold it exactly in half, one side completely covers the other with no little bit sticking out. That fold, the crease you just made, that, my friends, is its line of symmetry. Now, let's apply this to an actual shape. Look at this figure here. If we draw a line right down the middle, you can see the left side is a perfect mirror image of the right. You could literally fold it along that dotted line, and it would match up perfectly. So this figure has exactly one line of symmetry. But wait a minute, can a shape have more than one folding line? Oh, absolutely. Take a look at a square. You can fold it in half from top to bottom. You can fold it from side to side. You can even fold it corner to corner along both diagonals. Each and every time, the halves match perfectly. So a square doesn't just have one, it has 4 lines of symmetry. Okay, time for a little question. What happens when a figure looks balanced? It looks symmetrical, but you can't find a perfect folding line. What do we do then? Well, if folding doesn't work, we try spinning. I want you to think about a ceiling fan or a pinwheel. You can't really fold it in half, can you? But it still looks perfectly balanced. This brings us to our next amazing idea, rotational symmetry. Rotational symmetry is basically just a spinning test. Imagine you put a pin right in the center of a shape and you give it a little turn. If it looks exactly the same as it did at the start before you've completed a full 360-degree spin, then it has passed the test. It has rotational symmetry. Look at this pinwheel. If you turn it just a quarter of the way around, that's 90 degrees. It looks exactly the same. Turn it another 90 degrees, and guess what? It looks the same again and again. This is a perfect example of rotational symmetry. And let's go back to our good old friend, the square. It not only has line symmetry, but it also passes the spinning test with flying colors. If you spin it 90 degrees, or 180 degrees, or 270 degrees around its center, it looks identical every single time. And since it looks the same in 4 different positions during one full spin, we say it has a rotational symmetry of order 4. And now it's time for the grand finale. Let's see how some incredible objects have both types of symmetry, which makes them extra special and perfectly balanced. And what better example than our very own Ashoka chakra? It's just a masterpiece of symmetry. You can draw so many lines of symmetry through it, cutting it into perfect mirror halves. And when you spin it, it looks the same after every tiny little turn. It is a fantastic example of having both line and rotational symmetry. Now, this slide here is exam gold. Seriously, take a screenshot if you want. It's a quick revision table. A square has 4 lines and order 4 rotation. A rectangle has 2 and 2. An equilateral triangle, that's 3 and 3. And a circle? A circle is the champion of symmetry, with infinite lines and infinite rotational symmetry. Okay, Now for the most important part. You've understood the concepts, which is great. But how do we use this knowledge to score full marks in the exam? Let's find out. So here is a typical question you might see in your paper. How many lines of symmetry does a regular hexagon have? Now remember, a regular hexagon is just a shape with 6 equal sides. So how are we going to solve this? First thing, don't panic when you see the shape. Just take a deep breath. We are going to solve this together, step by step. Okay, first let's draw lines connecting the opposite corners, or vertices. That gives us 1, 2, 3 lines. But are we done? Not yet. Now let's draw lines connecting the middle points of the opposite sides. That gives us 3 more. So we just add them up. 3 plus 3 gives us 6. A regular hexagon has 6 lines of symmetry. Easy peasy. So let's do a super quick revision for your brain to lock this in. Line symmetry is the folding line. Rotational symmetry is the spinning test. The center of rotation is that pin in the middle you spin it around. And here's a superstar shortcut. For regular shapes like an equilateral triangle, square, or hexagon, the number of lines of symmetry is always equal to the number of sides. See? I told you it was easy. You are now a master of symmetry. You have understood everything perfectly. So please go into your exam with full confidence. You've totally got this. Don't stress about it at all. And before you go, here's a little thought for you. Now that you have these special symmetry eyes, open them up to the world around you. What beautiful symmetry will you find today? Maybe in a leaf, or a building, or even on your dinner plate? Let me know. All the very best.